Hi everyone, so in this video we're going to be talking about probability. So, assuming the outcomes of an experiment are equally likely, the probability of event E occurring is the number of ways E can occur divided by the total number of outcomes. So, we've already been talking about this total number of outcomes part. That's where we were doing permutations and combinations so that we can figure out how many possible ways things can be done. Only difference is now we have to figure out how many ways this specific thing can happen and divide it by that total. Alright, so we're going to start easy. If we have this spinner, then we're going to use that spinner to answer the following questions. First, what is the probability of spinning a 4? Well, there's 4 different possible outcomes. So we know that that's going to be at the bottom of a fraction. And the actual outcome that we want is to get the 4, and there's only one of those. So 1 out of 4. What is the probability of spinning an even number? Well, there's still 4 total possible outcomes. But if we want an even number, both 2 and 4 are outcomes that we would want. So there's 2 outcomes that we would want. Then we can just reduce that. So 2/4 becomes 1/2. Alright, what about the probability of spinning a 5? So there's still 4 possible outcomes. And how can we spin a 5 on here? Well, we can't. There is no 5 on this spinner. So there's 0 ways to get a 5, which means the probability is just 0. Because we can't actually spin a 5. There is no 5. What is the probability of spinning a number less than 5? Well, it's still 4 total possible outcomes. And all 4 of these are less than 5. So it's 4 out of 4 or 1. So that means it's 100% certain that we're going to get something less than 5 because everything on the spinner is less than 5. We can't get anything that is 5 or bigger. Alright, so probabilities can be expressed in what 3 ways? So as we've just seen, a fraction, and that's the one we're going to be using the most in this, but it can also be written as a decimal or a percent. Probabilities have a value between what 2 numbers? Well, for a fraction or a decimal, that'd be between 0 and 1. Or if we're talking about percentages, between 0% to 100%. And just keep in mind, 0 means it's completely impossible, it cannot happen. 1 means the opposite, it means it's guaranteed to happen. Alright, at a local high school, 150 students were randomly selected and polled to see who they would vote for in the next student government presidential election. The results are as follows. Captain America got 52 votes, Spider-Man got 54 votes, and Thanos got 44 votes. Based on these results, what would be the empirical probability that Spider-Man is elected president? So all we're going to do is we're going to take the number of votes Spider-Man got, which is 54, and divide it by the total, which is 150. So in this case, it can actually be reduced into 9/25. And that would be our answer. what is the probability that Spider-Man is not elected president? Well, we have two different ways that we could do this one. The first is we can just add up the other votes. So if we do 44 plus 52, that gets us 96. So 96 out of 150 people did not vote for Spider-Man, which would get us 16 out of 25 if we reduce it. The other way that we can think about it is, well, if we already know that 9 out of 25 is the probability for Spider-Man, then if we just do 1 minus that 9 over 25, we also get straight to our answer. Either one works, you're going to get to the same place either way. All right, let's talk about a die being rolled. So this is just a normal die with 1, 2, 3, 4, 5, 6 on its faces. So what is the probability of getting a 6? Well, there are 6 total possibilities, and only one of those is a 6. So 1/6. Probability of getting an even number. Again, 6 total possibilities. And 1, 2, 3 of these are even. So if we reduce that, we get 1/2. All right, next, a number less than 5. So still 6 total possibilities. If we want less than 5, then that would be 1, 2, 3, and 4, which is 4 total possibilities, which gives us a probability of 2/3. Probability of rolling a 7. Well, there is no 7. So 0 out of 6, or just 0. Or probability of rolling a positive number. All 6 of these are positive. So that's 6 out of 6, or 1. All right, making it a little more difficult. This time we are going to be rolling 2 dice. And we're going to find the following probabilities. So for this one, you're going to want to bring up the first notes where we talked about sample space and bring up that second example. So it's this one right here where we talked about the whole sample space for 2 dice being rolled. And specifically what we're looking for now is we're going to be talking about the sums. So the sums were these. So for example, whenever we're talking about the probability of getting a 2, the only one to get a sum of 2 is getting 1 and 1. So if we go back to our problem, the probability of getting a 2, there's one way to get a 2 out of those 36 total possibilities for rolling 2 dice. So that would be our answer. All right, what about the probability of getting a 5? Well, again, if you look at that same exact thing that I just showed you, you would see that to get a 5, there's a 1 and a 4, a 2 and a 3, a 3 and a 2, or a 4 and a 1. That's 4 different possibilities. That's 4 ways to get a 5 out of our total 36. We can reduce that into 1/9. Probability of getting a 7. Again, if we look at the sample space, to get a 7, we can get a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, or a 6 and a 1. That's 6 different possibilities out of our 36 total, or 1/6. All right, probability of getting an 11. Go ahead and try this one on your own real quick. See if you can find them in that table. And then see if you can find the probability and reduce it. Pause the video if you need more time. But here is the answer. 1 out of 18. Because there are 2 different ways you can get an 11. So 2 out of 36 equals 1 out of 18. All right, another spinner. So we're going to find the following probabilities. The probability of getting a 1. All right, so if you notice, this spinner is a little different because the 1 covers this entire half. We can't say that it's 1 in 3, even though there are 3 different numbers we could get. We can't say it's 1 in 3 because we can clearly see that this side is much more likely, right? So if we want to make this one a little more clear, let's go ahead and cut this one into fourths. And this would also be 1 down here. So now it's a little bit easier because they're all equal sections. So we have 4 different possibilities. And a 1 is now 2 of them. So that's 2 out of 4, or 1/2. All right, the probability of getting a 2. There's only 1 2 on there, so that's 1 out of 4. And the same exact thing with 3. There's only 1 of them, so also 1/4. All right, we are now going to start talking about a deck of cards. So just in case you haven't seen a deck of cards before, I'm going to give you some basic information about them. I highly recommend just Googling a deck of cards and pulling up a picture that you can see what I mean. On the next set of notes, whenever we use this a lot more, I will go ahead and provide you a picture of them on the notes. For now, I just want to say some basic things about them. Okay, so a normal deck of cards has 52 cards in the deck. The suits are the different symbols on the cards. So there are hearts, spades, diamonds, and clubs. For each suit, there are 13 cards in it. So there are 13 hearts, 13 spades, 13 diamonds, and 13 clubs. Those cards are the numbers 1 through 10, except for instead of 1, we call it ace. So ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there is a jack, queen, and king. The jack, queen, and king are called face cards. And that's because they're literally the cards that have faces on them. They actually have little people. So when you draw a card from the deck, how many possible outcomes are there? Well, that's just the total number of cards in the deck. So there's 52 different outcomes because they are all different cards. Okay, so let's go ahead and do a little bit of probability with cards. So first off, don't forget all of these are going to be out of 52 because there are 52 cards in the deck. So probability of getting a 3. So remember, each specific number has 4 of that number in the deck. Because there is a 3 of hearts, 3 of spades, 3 of diamonds, 3 of clubs. It's 4 different 3s that are in the deck. So that's 4 out of 52. We can reduce that to 1 out of 13. All right, the probability of not a 3. Well, if 4 of those cards were 3, then that means the other 48 are not 3. You could also add up all the aces, all the 2s, all the 4s, and so on. But if we know 4 of them are 3, then the other 48 are not 3. That is going to be 12 out of 13. All right, the probability that the card is a spade. So remember, each of these suits has 13 cards in it. So there are 13 spades, and we can reduce that into 1/4. The probability that the card is red. So this is one thing we haven't talked about yet, but out of hearts, and diamonds, all of those cards are red. And out of spades and clubs, all the cards are black. So whenever it says a red card, that is going to be all the hearts and all the diamonds, which is 26 cards, or 1/2. All right, probability that we get an even number. So the even numbers are 2, 4, 6, 8, 10. So that's 5 different numbers that are even. But remember, each number has 4 cards. So if each of those have 4, then that means there's 20 total cards that have even numbers on them. So that's 20 out of 52, which again we can reduce into 5 over 13. All right, probability that's a face card. So remember, Jack, Queen, and King are 3 face cards. Each of those have 4 cards. So there's 4 jacks, 4 queens, 4 kings. So that's 12 out of 52, or 3 out of 13. Here's where it gets a little bit tricky. So the probability of it being a spade and a diamond. So keep in mind, we're only drawing 1 card, right? So 1 card is either going to be a spade or a diamond. It can't be both. It's going to be one of those two. So that's 0 out of 52, or just 0. All right, what about probability of 2 or 3? Well, there's 4 2s and 4 3s. So that's 8 out of 52, or 2 out of 13. Lastly, probability that it's not a face card. So again, we can add up the numbers ace through 10, and then 4 of them each, so times 4. Or we can just say there were 12 face cards. We already did that here. So the other 40 must not be face cards, which is 10 out of 13. All right, moving on from cards now. Next up is going to be coin probabilities. So starting off, we are just going to be flipping one coin. So remember, for one coin, we can either get heads or tails. Those are our two possibilities. So that's our first one. What's the probability of flipping heads? Well, heads is one of the choices out of the two, so it's 1/2. Probability of flipping tails, same thing, there's only one possibility out of the two, so still 1/2. All right, what about the probability of flipping heads or tails? Well, if we want heads or tails, that's two possibilities out of our two, which means it's 1, which makes sense. You can't flip a coin and not end up with heads or tails. All right, what's the probability of flipping a 4? Well, there's nothing on a coin that is a 4. So it's just 0 out of 2. That's 0. All right, next up, we're going to flip a coin twice. So for this one, we've done the sample space for this before as well, but we can get a heads and a heads and a tail and a heads, or two tails. Those are the 4 different outcomes that we could have, which means all of these are going to be divided by 4. So probability of getting two heads would be HH. That's 1 out of our 4 possibilities. Probability of getting a heads then a tails. So heads, then tails. Again, that's 1 possibility. It's this possibility right here. So that's 1 possibility out of our 4. Lastly, probability of getting 1 is heads and 1 is tails in any order this time. The in any order is important because that means it could either be heads then tails or tails then heads. Both of those satisfy that. So that'd be 2 out of 4 or 1/2. All right. The rest of these are going to be based on a survey that another professor and I actually asked our classes. So these are results from some of the students. So first off, in the survey conducted, there were 37 freshmen and 13 sophomores. What is the probability of randomly selecting a freshman? Okay, so first off, 37 plus 13 means there was a total of 50 students in the survey. So if we want a freshman, that was the 37. So 37 out of 50. And that one doesn't reduce, so we get to leave it like that. All right, Professor Curian asked 50 students which one they would put first. Milk, cereal, or do not like either one. The results are below. So reading these results, this first row just means that there were 29 freshmen who put cereal first, 1 freshman that put milk first, 7 freshmen that didn't like cereal. There were 9 sophomores who put cereal first, 4 sophomores who put milk first, and then 0 that didn't like cereal. So, what's the probability of randomly choosing someone who puts milk first? So, keep in mind, milk first is this entire column. So we know there's 50 students total in the survey, so we know it's going to be out of 50, but we don't put the 1 or the 4. We actually need to add these up because there's a total of 5 students that put milk first, 1 freshman and 4 sophomores. So that's 5 total students. Divide both those by 5, and we get 1/10. All right, what about somebody who puts cereal first? Same thing, but different column. So this time we're looking at the cereal column. If we add 29 and 9, that is 38 out of 50. And we can divide both these by 2 to get 19 out of 25. All right, in another survey, they were asked whether they prefer iPhone, Android, or don't care. The results were 39 were for iPhone, 10 were for Android, and 1 didn't care. So, find the following probabilities. Randomly choosing someone who chose iPhone. Well, if there was 39 people who said iPhone out of the 50, then that's our answer. That one doesn't reduce, we get to leave it like that. If we say randomly choosing someone who did not choose iPhone, again, we have our 2 options. Either first, we can do, if there was 39 people who did choose iPhone, the other 11, which I'm just getting by doing 50 minus 39, must not have. So that'd be our answer. Or you could have also just taken the number of Androids and the number of don't care answers and added those together. You'd still get 11. Either way works. All right, another table. So in a recent survey, 50 students were asked whether they preferred The Office, Friends, How I Met Your Mother, or none of those. The results are below. So we're going to find the following probabilities. First, randomly choosing someone who prefers The Office. So we know it's going to be out of 50 because these are still 50 students. And we're looking at the Office column. In this case, we actually made it a little easy for you. It already has a total at the bottom, so we don't have to add up the freshmen and sophomores. That's already been done for us. So it's the 19 out of 50. Someone who prefers How I Met Your Mother. We look at that column. It's a total of 4. So it'd be 4 out of 50. That one does reduce, so that's 2 out of 25. All right, randomly choosing someone who prefers Friends. Friends is this column. So that's 10 out of 50, or 1/5. And randomly choosing someone who does not prefer How I Met Your Mother. So again, 2 things you could do. Either we could add up all of these other categories other than How I Met Your Mother and put that over 50. Or, since we already know that there was 4 people who prefer How I Met Your Mother, then we can just subtract that from 50. We know that the other 46 must not have. So 46 out of 50, which we can reduce. So that's 23 out of 25. Last one. In a certain ACM ABS course, 50 students asked whether they were weirded out by the survey we gave them. There were 33 students who responded no and 17 who responded yes. What's the probability of choosing someone who responded yes? Again, this one's nice and easy. We know it's out of 50 still because that's the total number of students. If we want the people who responded yes, we see that there was 33 of them. Doesn't reduce, so 33 out of 50 is our answer. All right, so that's it for our basics on probability. In the next video, we're going to go a little bit deeper and talk about some keywords and how to deal with those keywords whenever doing probability. So I will see you in that video. Thank you.